So the last section that we're going to be doing, again, doesn't have anything to do with trig. That happened to be in the last chapter. It's something we should have thrown into Math 108, but we ran out of time, so we put it into Math 109. It is needed for calculus, and there's a couple notation things we'll talk about. But before we were doing a sequence, now what I want to do is I want to find the sum of the sequence. So remember, a sequence is either arithmetic or geometric. Arithmetic has the D, so that's what we call arithmetic. We're either adding or subtracting. So an arithmetic series is we're just going to sum the arithmetic sequence. So the two kind of words that you need to know: sequence is a list of terms, series is the sum of the sequence. So we have notation. We use the letter S. So S stands for sum. That's why we put S there. And then we put this little subscript N. And N is the number of terms to sum. Okay, so if I take a look at these 5, I'm going to sum these 5. So S of N is going to be S sub 5. So I can specifically state it for that. And I'm just going to total those up. Now, when I look at totaling things, I'm often trying to make tens and be efficient and not go 3 plus 8 is 11, 11 plus 13. Sometimes I like to make tens. I don't see any tens, so sometimes I like to do this. So that's a 26. There's a 26. And here is a 13. So I can see that that's 52 plus 13, which is 65. So it's just a matter of being efficient. Okay, you could have taken your calculator up and done the same thing. But I showed that for a reason, because it happens to help me develop the formula for an arithmetic series. I can always add it up on my calculator, okay, but sometimes the numbers, they're a lot. So there was this guy, when he was a kid, he's a mathematician, his name is Gauss, and when he was in the lower elementary grades, he was always pretty active guy, and so his teachers were always trying to keep him busy. In other words, he was probably too smart for his peers and probably his teacher as well. And so one teacher specifically asked him to add up all the numbers from 1 to 100. Just give me that sum. And so, thinking it would take him a long time, it took him less than a minute. So how did he do it so fast? I tell you, he didn't go 1 plus 2 is 3, 3 plus 3 is 6. That takes way too long. So let's try that same technique I used earlier. If I add these up, I get 101. If I add these 2 up, I get another 101. If I add 3 and 98, I get another 101. So I'm going to keep getting 101s. And I don't want to list them all out. There are 100 numbers, and they're going to be paired, okay, in groups of 2. So there's going to be 50 pairs. So you might say, well, what happened to the middle number? The same thing that happened here. What's half of 26? 13. So essentially this would be 101 times 50, and that would be the sum of the first 100 numbers. So let's build that into a formula. So S of n, the sum of any amount of numbers I want to take in an arithmetic sequence, I'm going to add them up and make this series, is I'm going to take the first number and add it to the last number in the sequence. And I'm going to partner them up in pairs. So I have n numbers, and I'm going to divide them into pairs. So a sub 1 is the last number. Excuse me, a sub 1 is the first number, a sub n is the last number, and n is how many pairs you're going to have. So if I wanted to apply it to what I know is 65, it's going to be 3 plus 23, and then there's 1, 2, 3, 4, 5 over 2. So if I add this up, that's 26. Half of 26 is 13 times 5, which would give me that 65. Okay, so sometimes it's easier for me to add than it is to multiply by the 5. So this is the notation that you kind of need to be familiar with. Okay, this symbol right here, okay, this symbol is a capital letter. It's a Greek letter called sigma, and it means to sum up. So it's just a shortcut. Okay, it doesn't do anything for me, but it takes something that's expanded out and simplifies it. So we have to notice a little notation here. You have this little k equals 1. This number down here, that's my start for the input into the formula. And this number up here is the last number I'm going to input, so it's my end input. And we're going to increment, that means count, by 1, and it's always by 1. This notation does not change. What might change is the start and the end, but never the increment and never the sigma. So if I look at this, it says put 1 in there, increment, and get to my second term of my series, put in 2. So k is incrementing by a value 1, and it's counting up. So that would be a 3. So I continue to put into my value k the next increment. 1, 2, 3, I'm going to put in 4. And how do I know when to stop? As soon as my input is 4. And so what did this really do for me? It just simplified things. So 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. 2 times 3 is 6 plus 1 is 7. So it looks like I'm getting the odd numbers. And I have 4 numbers, 1, 2, 3, 4, my increments. Doesn't sum it for me. It's just a shortcut notation. So now let's move on to a geometric series. So as you can guess, this has the R, and it's going to be the sum of I'm going to abbreviate this, geometric sequence. Again, it has the same notation. And instead of deriving the formula for this, it's really not that difficult to derive. It just takes time. And I feel like probably not what you want to be listening to the last week of the quarter. So here is the formula. Do you understand what a sub 1 is? The very first term of the sequence. And I repeat it. And I'm going to multiply this by a bunch of r's. Now, when we did the sequence, it was 1 less r because the first term didn't need it. Now I'm going to take it to the nth, or the number of terms, and we're going to divide it by 1 minus r. If you're interested in seeing that formula derived, please let me know and I can do that for you. It'll take us about 5 minutes. Okay, so how does this formula work? So here's some information. I want to sum these. You might say, well, first of all, where would I even sum something like this? This would have to do with a multiplicative sequence, which happens quite often. So to give you an application, there'll probably be one in the homework problems, but I wouldn't get too worried about that right now. We're just trying to get a grasp on this formula so when you see it again, you have an idea. So I'm going to sum up the 6 terms. And my first term is 2. So I'm inputting 2 in for a sub 1. Now I need to find r. How did I go from 2 to negative 6? Remember, this was the division of consecutive terms. And if I look at that every time, it looks like r is negative 3. So I'm going to put negative 3 in for the r value. And then I'm going to raise it to the power of n. N is the number of terms, which is 6. So these are the n's. I'm going to divide it by 1 minus negative 3. So when doing that, I can simplify. The denominator is 4. And I'm going to have 2 minus. Remember, you can't subtract those. You have to multiply this out. And I'm going to get 2 times negative 3 to the 6th power is going to be a positive 729. And you can do that on your calculator. I would certainly expect you to do that. Double 729, and I get 1,458 divided by 4. So let's subtract first. And it's going to be 56 divided by 4, and it goes in there nicely as negative 364. So that would be the sum. Okay, you're still going to have to use a calculator. Okay, but it's just a shortcut for this whole list because sometimes our list is very long. So we can do the summation notation the same way. Notice I changed the start value. So if I apply it here, it looks like it's going to replicate that series, just condensed. So instead of writing out all these numbers, 6 numbers, it's just condensed it. But I am going to write out the 6 numbers so you can see how this works. Summation, that's what sigma notation means. 2 times negative 3 to the first, 0, 1. And then it's going to be negative 3 to the second. So 0, 1, 2. How do I know when to stop? Okay, I just continue to do this. There's 3. There's 4. And there's 5. This would be a 3 to the 5th. How did I know when to stop? That 5 told me. How many terms are here? 1, 2, 3, 4, 5, and 6. So there are 6 terms. That's what it asked me to do. And if I simplify this, I can show you that it's the same sequence listed above. It's just the shortcut notation. A power of 0 makes 1 times 2 is 2. Negative 3 times 2 is negative 6. 9 times 2 is 18. And it would continue. So just briefly, there are two separate formulas, one for the arithmetic series, which is the sum of the sequence, and one for the geometric series, which is the sum of a geometric sequence. Notice one has R in it. This one doesn't even need a D, but we saw how they paired up. So you'll be using these two formulas in the homework. The homework's very short. I just want to make sure that you have a grasp of this. In addition, we'll put some of these in here so you understand that you can the start value, the end value, and how all of that works.